Moving forward towards our 8th session of this one-week training program, it is our proud privilege and fortune to welcome Dr. Haseeb Athar Sir, Department of Statistics, Aligarh Muslim University, as the resource person of the session titled Application of SPSS in Research. Dr. Haseeb Athar Sir has more than 17 years of teaching and 22 years of research experience. His areas of research are statistical interference, order statistics, and record values. Dr. Haseeb Sir has got published more than 70 research papers in peer-reviewed journals. He also contributed to a research book entitled New Development in Applied Statistical Research, edited by Professor M. Ehsanullah and published by Nova Publication, USA. He has good experience in data analysis and has delivered several invited lectures as a resource person in the workshop on data analysis using SPSS organized by UGC Academic Staff College, Aligarh Muslim University. So may I request our resource person, Dr. Haseeb Athar Sir, to enlighten us with his knowledge.
Okay. Thank you. Dear participants, Assalamu alaikum. So today's session I shall start. Actually, I have given topic what's the use of SPSS in our research. So basically, I would like to just introduce the concept how to use SPSS in your research. But before coming on to the main topic, some basic concept is to be given. I hope Dr. Shah Mohammed Sahab already discussed some basic concept regarding hypothesis testing. I'm also from the inferential analysis field. My area of research is statistical inference. So a little bit I will also just continue from there, and I'll just introduce some basic concept. That means because when you are going to deal with your research problem, you must know which type of data you are going to deal, because according to the data type, your tools available with the statistics will also be differ. Sometimes you have the categorical data, sometimes the quantitative data, sometimes the qualitative data. Accordingly, your research tools will be also differ significantly from one problem to another problem. So I will start from basic concept, that is the data type, and these are the outlines of my discussion today. First, I shall discuss the data types and method of its analysis, and concept of parametric and non-parametric test, because in the statistics we deal with two types of test. One is the parametric test and another one is the non-parametric test. And if I'll get time, I'll discuss both types of test. And third one is concept of hypothesis testing. I will give in very brief because already Dr. Shah already discussed with you. And here basic thing will be start from the creation of data file in SPSS, how to create data file in SPSS, and detection. And after creating the data file, first I will tell you how to detect the outliers and what's the concept of outliers in the data file. And one thing is also very important after creating data file, to check the normality assumption of some variables which are the quantitative in the nature. And after that, I will introduce with some parametric tests and some non-parametric tests. Okay. So here, first you may be knowing data is broadly classified into two types. One is the categorical data and another is the non-categorical data. Categorical data, we also say the qualitative data, and non-categorical data, that is the quantitative data. And accordingly, analysis will also differ, just I told you. So categorical data, that means whatever data you collected, that can be classified on the basis of some attributes. Okay. So here there are some examples of categorical data. Suppose eye color. So persons can be categorized on the basis of eye color, gender, economic status, attitude to debt penalty, strongly disagree, like 5-point Likert scale. Sometimes you provide questionnaire to the respondent that contains the 5 options, that is called the 5-point Likert scale, sometimes 7-point Likert scale is also available. So after collecting data, you can classify how many responded given the are highly agreed or neutral, like that. So you can categorize the respondent according to the on the basis of their answers. So basic thing is that when data is can be classified on the basis of some attribute, that is called the categorical data. Simple thing is that. And after that, this categorical data can also be classified into 2 parts. One is the nominal data, another one is the ordinal data. आप SPSS में जब करेंगे data file create करेंगे, so we have to give which type of data you are creating or considering, whether it is a numerical type of data or a quantitative data or qualitative data. This is nominal data or ordinal data, like that. So nominal data, that means if there is no need of any intrinsic ranking, लिखने की जरूरत नहीं है, I can provide these slides, so no need to write. So nominal data, that means there is no need for any, there is no reason to rank the data. Suppose gender, anyone can be written first, either male can be written first or female can be written first. On the category, suppose you are grouping on the basis of religion, so any one of the religions can be written first. There is no any reason to write any religion first. So if there is no reason to rank the data, obviously this is a categorical data, but there is no reason to rank the data. That is called the nominal data. And in contrast to that, if you can order the data, then it is called the ordinal, as per its name, the ordinal. That means order exists. So ordinal data, in that we can order the data. That means degree of illness, that is none, mild, moderate, high fever, suppose on the basis of fever, and level of happiness, very unhappy, happy, okay, happy, very happy, unhappy, like that. You can order the data. That is called the nominal and ordinal data. And similarly, when you come on to the quantitative data, also this type of data is classified into 2 parts. One is the discrete data, another one is the continuous data. Discrete data is very simple data. That means if we can count data, that is called discrete data. Suppose number of children in a family, number of students passing the exam, you can easily count the numbers, number of apples in the basket, like that. That means if you can count the data, numbers, that is the discrete data. And continuous data, data which cannot be counted, but it can be measured on some scale. अब जैसे height, that cannot be counted, you can measure on a scale, 5 feet 6 inches, 5 feet 4 inches, like that. And suppose weight cannot be counted, it can be measured only kilogram, gram, like that. So when data can be measured on some scale and it cannot be counted, that is called the continuous data. There are some examples of continuous data here. And there is one thing more here with continuous data, measurement of scale. That is very important. And continuous data can be measured on 2 types of scale. One is interval scale and another one is the ratio scale. There is a little difference between these 2 types of scale. In first type, there is no absolute zero. That means 0 degree does not mean, suppose we are considering the temperature, 0 degree doesn't mean no temperature. अगर आप इंटरवल स्केल में 0 डिग्री, बेसिक दोनों में डिफरेंस जो है 0, एब्सोल्यूट 0 का डिफरेंस है रेशियो एंड इंटरवल स्केल में. इन इंटरवल स्केल देयर इज नो मीनिंग ऑफ एब्सोल्यूट 0. इफ यू से 0 degree temperature, that means it doesn't mean no temperature. But in ratio scale, if you say 0 age, that means person doesn't exist. कोई 0 age है, that means है ही नहीं कोई. So here meaningful 0, but there 0 degree means very low temperature, means freezing point, like that. So there is a basic difference between interval scale and ratio scale, that there is no meaning of absolute 0, but here meaning of absolute 0. Now come on to the data analysis. Since just we classified data, and collection of data we may be knowing, we may collect data through in two types. One is through census survey, another one is the sample survey. अभी कुछ डिस्कस किया था उन्होंने डॉक्टर साहब ने हमसे पहले, हाउ टू कलेक्ट द डेटा किया था. We can collect data in two ways. One is census survey. In census survey, actually, what is the basic concept or basic objective of studying statistics? Statistics जो हम study कर रहे हैं या आप अपने research में जो statistics लगा रहे हो, why are you using some statistics in your research? Question arises here, and answer should be known. ऐसा तो नहीं कि just you are collecting some data and you are applying some statistical test and writing your result and submitting your thesis, that's all. Actually, what you are going to do here in statistics, two things are basic. One is population, another is sample. Okay, and population is totally unknown to us. Population may be sometime finite population, sometime infinite population. This class may be also regarded as a population. And here there is no problem. I can deal with each and every unit of the population, and every student will be called the unit of the population. And we can collect information from every student, and our result will be the more precise. But it is not always possible, because sometimes data may be large, data population may be large. There may be some, suppose population of Aligarh Muslim University, suppose there are 50,000 students or 40,000 students, and just we want to know average monthly income of the their family. So it will be very difficult when you are going to ask every student what is the monthly income of your family like that, and after calculating the mean, then you'll get the monthly income of the students of Aligarh Muslim University, Aligarh. Sometimes, so what would be the next remedy to come over the problem, overcome this problem? So we take a sample from that population, and samples should be taken in such a way that it should be the true representative of that population. ऐसा नहीं bias. Sometimes we take the convenient sampling. Suppose sometime हमको लेना है sample. Suppose just I collect data from the first row. This is called the convenient sample, but this is never be the good sample. So we always try to take a random sample. In that, probability concept is involved. Any one of the possible unit of the population can be taken randomly along with some probability. So probability sampling, there are two types of sampling procedure: probability sampling and non-probability sampling. Just I told you, in non-probability sampling, there is some biasness. There is a convenient sampling, quota sampling, like that. Suppose I fix quota from this part, we have to take 4 units, from this part we have to take 4 units, and without any randomness, we just going to and collect information from those individuals. Okay, but when we perform the random sampling, so any one of the unit can be selected in my sample, and our result will be more precise and good. Okay, so there are some sampling techniques we may be knowing. You may be knowing that simple random sampling, stratified random sampling, systematic sampling, cluster sampling. There are several procedure sampling scheme that can be adopted to get a good sample. वहाँ पर भी situation different है. Suppose we are performing the simple random sampling. Suppose this is the population. If I take a simple random sample of size, suppose 5 students, and what we'll do, we'll write roll number of each participant on a slip, and we'll put on the box, and randomly I'll pick 5 slips, and content will be noted down. Okay, so there is possibility that, and we are just going to observe what is the performance of the student in that class. So all the very good students may be selected in my sample, and on the basis of that, inference can be made wrong. अगर 5 के 5 स्टूडेंट्स हमारे बहुत अच्छे आ गए और उनके मार्क्स हमने रिकॉर्ड कर लिया, तो इन्फ्रेंस रॉन्ग ड्रॉ हो जाए, क्योंकि हम कंक्लूजन ड्रॉ करेंगे क्लास बहुत अच्छी है, जबकि हमारे 50 में से 45 स्टूडेंट के मार्क्स बहुत बेकार हैं. तो इफ पॉपुलेशन इज हेट्रोजीनियस, if population is homogeneous, there is no problem in taking simple random sampling. But if population is heterogeneous, that means units differ significantly from each other. So what we do sometime, we divide whole population into different parts, that is called strata, and singular is stratum. Suppose we have to take a sample of size 10 or 20. So from each stratum we take a sample n1, n2, n2 like that, so that total of those observations should be equal to small n. तो जब 25 का सैंपल लेना है, कहीं से आपने 5 का ले लिया, कहीं से 4 का ले लिया, कहीं से 9 का ले लिया, इन सच वे दैट जब आप ऐड करें वो 25 हो जाए. तो इन दैट केस रिप्रेजेंटेशन जो है पूरी क्लास का हो जाएगा. अब इस क्लास को हमने 4 पार्ट्स में डिवाइड कर दिया. एंड इफ आई कलेक्ट टू इंफॉर्मेशन फ्रॉम टू स्टूडेंट फ्रॉम दैट पार्ट, some information from other part, so representation पूरे क्लास का हो गया. So result will be more better than earlier one. Okay, so this is a procedure for stratified sampling. Similarly, there is another procedure for systematic sampling. We select individual in some system. Suppose first student is selected after kth step. Suppose k we fix the 7. So first student is selected, then k plus 1 plus k is 7, so 8th student, then 15th student, like that. So we select like this. So there are some, I am not going in detail how to select the sample, just I told you some sampling techniques through that we can take a good sample from that topic. Basically just I want to tell you what is the purpose of sample. So through that sample we predict or analyze about that population, which is our main objective, basic objective, because we are always going to study about that population. आप अपने रिसर्च में क्या कर रहे हो? जो आप आर्किटेक्चर, सभी लोग आर्किटेक्चर के हो. मेरे कहने का मकसद ये है कि आप जो भी रिसर्च क्वेश्चन स्टेट कर रहे हो, वी आर नॉट गोइंग टू चेक दैट सिग्निफिकेंस इन दैट सैंपल. ऑन द बेसिस ऑफ दैट you are going to tell this is also true in the population with certain confidence. आप अल्फा फिक्स करते हो, that is error. 5% फिक्स करते हो after conclusion, after concluding hypothesis. If your result is significant, that means whatever you concluded, that is 95% correct in the population. If you take 100 samples, same result will be obtained in 95 samples. So alpha, that is the type of error, because when test we hypothesis, we commit 2 types of error, type 1 error, type 2 error, and we always try to minimize the errors. And in hypothesis testing, we cannot minimize both type of errors at a time. So what we do, we fix type 1 error, जो आप alpha fix करते हैं ना 5%, 1%. So we fix type 1 error and try to minimize type 2 error. अब उसके मेथडोलॉजी में नहीं जाना, वी क्रिएट द क्रिटिकल लीजन एंड थ्रू दैट वी रिजेक्ट और एक्सेप्ट नल हाइपोथेसिस. बट मेन बेसिक थिंग इज दैट इफ यू फिक्स अल्फा 5%, so after testing hypothesis, whatever you are concluding, that is 95% correct in that population from where you have taken the sample. अच्छा, ये तो आपका हो गया कि सैंपल के बेस पर आप जो है जो पॉपुलेशन के बारे में स्टडी कर रहे हैं. देयर आर 2 प्रोसीजर टू टेस्ट द हाइपोथेसिस. वन इज एस्टिमेशन थ्योरी, एंड एस्टिमेशन थ्योरी में क्या करते हैं कि जैसे कि वन स्टैटिस्टिक, देयर इज वन मोर थिंग, व्हाट इज डिफरेंस बिटवीन स्टैटिस्टिक एंड पैरामीटर. स्टैटिस्टिक इज नथिंग बट आफ्टर टेकिंग सैंपल, if you calculate the sample mean, sample median, like that, all are the statistic, and plural उसका जो हो जाएगा statistics हो जाएगा. और same thing if you calculate in the population, that is called the parameter. Suppose population mean, suppose average height of student in Aligarh Muslim University, you want to check average height of the student in Aligarh Muslim University. So mean value जो अलीगढ़ मुस्लिम यूनिवर्सिटी के जो स्टूडेंट्स का वो पैरामीटर होगा, और सैंपल लेके उसी एवरेज को कैलकुलेट करेंगे, दैट इज कॉल्ड स्टैटिस्टिक. सो इन एस्टिमेशन थ्योरी व्हाट वी डू, वी यूज स्टैटिस्टिक टू अप्रोक्सीमेट द पॉपुलेशन वैल्यू, दैट इज कॉल्ड एस्टिमेशन थ्योरी. बट इन हाइपोथेसिस टेस्टिंग यू जनरली डोंट यूज द एस्टिमेशन प्रोसीजर. जनरली यू टेस्ट द हाइपोथेसिस. इन हाइपोथेसिस टेस्टिंग व्हाट वी डू, we get some idea about the feature of the population. जो population जिसके लिए आपके रिसर्च स्टडी है, उसके बारे में कुछ आइडिया आपके पास फ्रेम होता है. सपोज एक आइडिया फ्रेम कर रहे हैं कि एवरेज हाइट ऑफ द स्टूडेंट इन अलीगढ़ मुस्लिम यूनिवर्सिटी अलीगढ़ विल बी 5 feet 6 inches, एक जस्ट assumption है, एंड you want to test whether this assumption is correct or not. How will test this assumption? So first we'll take a sample from that population. Sample should be the real true representative of that population, and on the basis of sample value what we do, we calculate the statistic, sample mean, we calculate the statistic, and after that we apply the appropriate test, and on the basis of that and calculate the p value or sometimes the value of the statistic. There are two methods for comparison, how to reject or accept null hypothesis. So one method is quantile to quantile comparison, I'll tell you, and another method is probability to probability comparison. हमने अल्फा बताया आपको क्या है जो फिक्स कर रहे हैं, that is the probability of type 1 error. Actually alpha is nothing but the probability of type 1 error. We commit two types of error, type 1 error, type 2 error. Alpha is the probability of type 1 error and beta is the probability of type 2 error. And type 1 error is reject H naught when H naught is true. आपने गलती से reject कर दिया H naught जबकि वो सही था, that is type 1 error. And accept H naught when H1 is true, that is type 2 error. And probability of type 1 error is alpha and probability of type 2 error is beta. So after performing some hypothesizing procedure, finally we conclude whether hypothesis is to be accepted or rejected. तो बेसिक जो मैं कहना चाह रहा हूँ कि आप जो पॉपुलेशन में जो चीज़ है, आप अपने स्टडी के बेस पर उस चीज़ को पॉपुलेशन में बताना चाह रहे हैं कि ये चीज़ एग्जिस्ट कर रही पॉपुलेशन में, क्यों क्या बताना चाह रहे हैं? ऑन द बेसिस ऑफ दैट गवर्नमेंट विल फ्रेम सम विल प्लान कि पॉवर्टी है कैसे दूर किया जाए, हेल्थ कंडीशन के बारे में आपका सर्वे है? तो जो आपने एनालिसिस की, कहा कि जो है पुअर हेल्थ स्कोर है या पुअर हेल्थ है यहाँ का जो है, क्या रेमेडी, और तो गवर्नमेंट कुछ प्लानिंग करेगी, ऑन द बेसिस ऑफ दैट सम प्लानिंग विल बी डन कि कैसे उनको पीने का पानी अच्छा दिया जाए, एटमॉस्फेयर अच्छा दिया, पोल्यूशन कम किया जाए, सारी चीज़ें प्लानिंग होगी। जो आप ऐसा नहीं कि सैंपल में आपने देख के बता दिया बस बात खत्म हो गई। ऑन द बेसिस ऑफ दैट गवर्नमेंट विल प्लान to provide good living conditions. So this is the basics for the hypothesis testing procedure and of how to take the sample. अच्छा, आप कोई बता सकते हैं कि sometimes we are bound to take a sample, there is no any another way to analyze. कोई ऐसा एग्जाम्पल आपके जहन में है विदाउट सैंपल काम ना चलता हो? बिना सैंपल का काम नहीं चलेगा। पॉपुलेशन का देखो, मैंने बताया कि सेंसस में census survey and sample survey. Census survey because we include each and every unit of the population. In sample we take part of the population. So my question is that, have you any idea where sample is necessary? Without sampling cannot analyze the complete population. ब्लड ग्रुप चेक करना है, सेंसस क्या होगा, उसका पूरा ब्लड खींच लिया जाए तो मर जाएगा वो तो। आप क्या करेंगे, 2-3 ड्रॉप से ही तो कर लेंगे। तो हियर सैंपल इज नेसेसरी, वी कैन नॉट टेक हिज और हर होल ब्लड। क्रैकर्स के पैकेट है एंड यू आर गोइंग टू बाई सम क्रैकर्स, तो क्या करेंगे, मिठाई जाते हैं लेने तो थोड़ा सा टेस्ट करते हैं कि ऐसा तो नहीं पूरी ट्रे उसकी खा लिया तब उसके बाद बताया कि लेना है तो कहेगा पहले पैसा रख दो तो फिर इसके बाद बात करना है तो यहाँ पर सैंपल के तौर पर आप कुछ भी लेते हैं, टेस्ट करते हैं, क्रैकर्स को बजा के देखते हैं सही, तो वो लॉट को एक्सेप्ट और रिजेक्ट करते हैं। एक्सेप्टेंस और रिजेक्शन ऑफ लॉट ऑन द बेसिस ऑफ सैंपल। तो समटाइम्स सैंपलिंग इज नेसेसरी एंड अलॉन्ग विद दिस प्रॉब्लम समटाइम्स सैंपलिंग इज नेसेसरी बिकॉज ऑफ द फाइनेंस। सपोज गवर्नमेंट ने आपको प्रोजेक्ट कोई दिया है और उसके साथ लिमिटेशन है, 1 लाख या 2 लाख का प्रोजेक्ट है, एंड व्हेन यू आर गोइंग टू एनालाइज डेटा इन द पॉपुलेशन, तो बजट से बाहर चला जाएगा। You have to evaluate each and every unit of the population, and budget is very limited. You cannot evaluate each and every unit of the population. That is census. Sometimes time constant. एग्रीकल्चर फील्ड में है, आप कोई फर्टिलाइजर यूज कर रहे हैं, 6th वीक में आप जो है उसका वेट देख रहे हैं या लेंथ देख रहे हैं क्रॉप की या प्लांट की। अब आपने एक तरफ से उसको मेजर करना शुरू किया, जब आखिरी तक पहुंचेंगे वो 3 वीक की जगह 6 वीक हो जाएगा। तो देयर आर सम प्रॉब्लम्स in dealing with the each and every unit of the population, and in these cases we are bound to take a sample, and through sample we analyze our population and conclude. ठीक है, तो वो पार्ट हो गया हमारा कि how to take a sample and what's the significance of taking a sample. Now come on to the data analysis, because after collecting sample, I told you there may be different types of data. Sometimes data may be categorical data, sometimes may be numerical data, and accordingly method of analysis will differ. And whatever statistical analysis will use in such a way that we get more information from the data. कैसे भी कोई भी टेस्ट लगाएं, जो appropriate टेस्ट वो टेस्ट लगाएं जिससे ज़्यादा से ज़्यादा इन्फॉर्मेशन हम निकाल सके। तो उसी चीज़ ड्यू टू ग्रेट डाइवर्सिटी ऑफ स्टैटिस्टिकल डेटा, मेथड ऑफ एनालिसिस एंड द मैनर ऑफ एप्लीकेशन डिफर सिग्निफिकेंटली फ्रॉम सिचुएशन टू सिचुएशन। एक बात मैंने कही, अक्सर मेडिकल साइंसेज के स्टूडेंट हमारे पास आते हैं जो एमडी कर रहे हैं, खासकर थीसिस, वो आएंगे तो हमसे क्या कहते हैं कि सर इस पर टी टेस्ट लगा दीजिए। तो आप बताइए क्या रिजनेबल है इस तरह से? मैं पलट के पूछता हूँ, तुम्हारे पास जाऊँ, हम तुमसे कहें कि ये दवा दे दो, वही बात होगी ना कि सिचुएशन के हिसाब से तो टेस्ट लगेगा। ये नहीं कि जो है आप देखेंगे ज़्यादातर, मैं अभी जो ऑब्जर्व कर रहा हूँ, अक्सर मेरे पास आते हैं, कभी लाइब्रेरी साइंस के आ रहे हैं, कभी कहीं से आ रहे हैं, कभी। अब एक साहब आए एक दिन जो कि हमारे यहाँ तो 2-3 थीसिस में यही लगा था। अरे लगा था तो लगा था, गलत लगा था, अब तो सही कर लो। तो हमेशा जो टेस्ट है अप्रोप्रिएट टेस्ट, दैट्स थिंग आई एम टेलिंग यू, अप्रोप्रिएट टेस्ट शुड बी अप्लाइड फॉर योर डेटा। ये नहीं कि पीछे लगाते आए लोग तो अब लगा लो। अब जेंडर का मीन निकाल लो तो जो 1-2 की कोडिंग कर रखा है तो उसका क्या मतलब है? तो one cannot possibly expect a single and unified system of techniques to be applicable in all cases. That thing I am telling you. तो सिचुएशन के हिसाब से जो टेस्ट है, एनालिसिस का तरीका है, डिफर करेगा। ठीक, बात समझ में आ रही कि नहीं? मेरे कोई प्रॉब्लम अगर होगी तो मुझे रोक देना बीच में। तो डेटा एनालिसिस को जो ब्रॉडली क्लासिफाई कर रहे हैं, one is the descriptive analysis, another one is the inferential analysis, and in both the cases inferential analysis is more powerful. अगर आप अपने रिसर्च में if you are using inferential analysis, that will be more powerful, because in descriptive analysis you are just writing some descriptive things on the basis of sample. You are not going to test your objectives or hypothesis. But in inferential analysis you are using some test, and on the basis of that test you are concluding your result with some confidence, 95% confidence, 99% confidence. Whatever you are concluding, that is 99% correct or 95% correct. So just I told you this inferential analysis can be classified in 2 parts, estimation theory and hypothesis testing procedure, and you people generally use the hypothesis testing procedure. But what we do in the descriptive analysis, this is the easier one. What we do, we calculate some basic statistics, mean, median, mode, and along with that we also create some graphs. We draw some graphs, bar diagram, pie chart, histogram, and some narrative things are written below that chart, and using that you can say this is the descriptive analysis. So, but inferential analysis is the more powerful than the descriptive analysis. Now come on to the test, because when we come on to the inferential analysis, so here we get 2 types of test. One is parametric test and another one is the non-parametric test. As per its name, parametric test means test based on the parameters. I just told you parameters, every population units follow some probability distribution, and probability distribution based on some parameters. So we test the parameters. So parametric test is based on the parameters, and non-parametric tests are parameter free test. That's why it's called the non-parametric test. And most of the non-parametric tests are given by the Russians. So, but when you compare the parametric and non-parametric test, so parametric tests are more powerful than non-parametric tests. And here, why sometimes we go for the non-parametric test. Here question arises, why we, when parametric test is available, why we go for the non-parametric test? Because most of the parametric test based on some basic assumptions. Basic assumption, that means observation should be the quantitative like that. It should be independently taken from the population. Distribution of the data should be normally distributed. Suppose your distribution is not normally distributed, so you will not forced to use some parametric test. Suppose t-test is the parametric test, and condition for the t-test is sorry, parent population from where you have taken your sample, that should be normally distributed. So before applying t-test, basic task is that first we will test whether data is normally distributed or not. If data is normally distributed, there is no problem. We can easily use the t-test. But if data is not normally distributed, non-normal or not normally distributed, then we'll apply the alternate test given in the non-parametric test. So non-parametric test will be used, and accordingly result will be connected. Procedure will be same, but test will be different. एक एग्जाम्पल में तो एक स्टूडेंट जूलॉजी या बॉटनी बहुत दिन पहले की बात, उन्होंने अपने रिसर्च में कुछ यूज किया, टी टेस्ट यूज किया, एंड शी सेंट फॉर पब्लिकेशन, एंड रेफरी इमीडिएटली कमेंटेड, व्हाई यू यूज टी टेस्ट फॉर योर गिवन डेटा. Suppose single mean is to be tested, and so obviously t-test will be used if sample size is less than 30. Until you are not knowing your data is normally distributed, why you use t-test? So she came to me, and I tested her data and found it was not normally distributed. The referee may be tested. So alternate test, I suggested alternate test, and after that paper was published. So when you apply any parametric test, first it will be better just check what are the underlying assumptions for that test. If all the assumptions are satisfying, then use the parametric test, otherwise you have the alternate test. Time मिलेगा तो मैं दोनों टेस्ट दिखाऊंगा, ठीक है? So these are the two types of tests, parametric test and non-parametric test. I just told you parametric tests are more powerful than non-parametric test. जैसे correlation analysis में आप करते हैं, स्पीयरमैन टेस्ट है और कार्ल पियर्सन correlation coefficient है. We calculate Karl Pearson correlation coefficient and Spearman rank correlation. So Spearman rank correlation is non-parametric and Karl Pearson correlation is parametric. इसीलिए वहाँ rank पर based है. That is not based on all the observations. ठीक है? These are some assumptions. Parametric assumption measurement scale should be, जैसे हमने अभी आपको बताया, that means on the scale quantitative data should be quantitative, observation should be independent, observation must be drawn normally distributed population. That is the very important assumption for the parametric test. This population must have the same variance. Suppose you are comparing two populations, so population variances should be same. अभी हम दिखाएंगे SPSS में why we are writing this, population variances should be same. And some parametric tests are Z test, but in SPSS we will not get the Z test, we will get the T test. T test is applicable for the when sample size is less than 30, but when sample size is more than 30, it will be approximated to normal test, that is Z test. So there is no need for a separate test in the software. So in SPSS only T test is available. When you are using a sample size more than 30, that is 50 or 100, it will be automatically approximated to the normal test. Okay. And F test for equality of variances, all are the parametric tests. And just I told you why we use non-parametric tests. These are listed here, and some non-parametric tests are here. Chi-square test. You frequently use the chi-square test. किया कि नहीं use कभी chi-square test? Chi-square नहीं किया कभी test? बहुत पॉपुलर टेस्ट है, जैसे टी टेस्ट भी बहुत पॉपुलर है, काई स्क्वायर भी. तो रेशियो को चेक करने के लिए हम करते हैं. रेशियो है या एसोसिएशन ऑफ एट्रीब्यूट है, जैसे लिटरेसी है, जेंडर है, उसके बीच में एसोसिएशन है. हाउ टू चेक एसोसिएशन बिटवीन लिटरेसी एंड जेंडर. So through that we chi-square test we check. टेस्ट ऑफ रेंडमनेस, टेस्ट ऑफ रेंडमनेस मीन्स सैंपल्स जो ले रहे हैं उसके ऑब्जर्वेशन इज वेदर ऑब्जर्वेशंस आर टेकन रैंडमली और नॉट, थ्रू नॉन पैरेटिव टेस्ट we can check whether sample observations are random or not. One sample colmograph is no test, वहाँ पर t test है सिंगल सैंपल के लिए, and alternate to that there is one sample colmograph is no test, that is the Russian name, and sign test and sign rank test and Kruskal-Wallis test, that is one way ANOVA, alternate of one way ANOVA, Kruskal-Wallis test. अब इसको मैं थोड़ा सा अगर बोलूँ तो स्किप कर जाऊँ क्योंकि हाइपोथेसिस टेस्टिंग उन्होंने डिस्कस किया है और आपको ये तो समझ में आ गया ना कि पी वैल्यूज के बेस पर कैसे हाइपोथेसिस को रिजेक्ट और एक्सेप्ट करते हैं, मालूम हो गया? बताओ दो जल्दी से एक बार हाउ टू रिजेक्ट और एक्सेप्ट है? नहीं, मैं इसलिए पूछ रहा हूँ कि अगर नहीं है तो मैं उसको एक बार फिर से बता दूंगा, ऐसा नहीं कि मैं आपसे क्वेश्चन कोई पूछ कर रहा हूँ, है बताया था ना, ठीक है, मैं इसीलिए इसको स्किप करना चाहता हूँ। तो एक चीज तो हो गया हाइपोथेसिस, एक तो नल हाइपोथेसिस और अल्टरनेटिव हाइपोथेसिस होगी, वॉट एवर योर प्रॉब्लम दैट विल बी स्टेटेड अंडर नल अल्टरनेटिव हाइपोथेसिस, जो रिसर्च क्वेश्चन विल ऑलवेज बी स्टेटेड अंडर द अल्टरनेटिव हाइपोथेसिस, और नल हाइपोथेसिस उसके कंट्रास्ट है। सपोज इफ यू ऑब्जर्व देयर इज सम सिग्निफिकेंस डिफरेंट between means of two populations, that will be stated under H1, and under H1 H0 will write there is no significant difference, ठीक है? After using some appropriate test we'll finally get the p value, and rule is that if p is less than or equal to alpha then reject H0, otherwise accept it, ठीक है? तो वो हम skip कर रहे हैं उसको। Now I will show you one problem, and using that problem first I will create the data file in SPSS, and after that here two things are here, one is detection of outliers and checking the normality of the data, क्योंकि अभी हमने बताया कि पैरामीट्रिक टेस्ट में नॉर्मलिटी अजम्पशन चेक करते हैं, तो पहले हम डाटा फाइल क्रिएट करना बताएंगे, हाउ टू क्रिएट डाटा फाइल इन SPSS, एक प्रॉब्लम हम आपको शो करते हैं और उसमें कुछ वेरिएबल्स की नॉर्मलिटी कंडीशन चेक करेंगे, ठीक है? ये बंद क्यों हो गया? ये PDF फाइल है, ये तो PPT आ जा रहा है। तो साथ में चलता है, नहीं एक आ रहा तो दूसरा भी आना चाहिए।
I would like to request the online participants to wait for 5 minutes. We're trying to figuring out the situation.
ये PDF फाइल नहीं है। पीपीटी तो बंद कर दें, हम अब पीडीएफ फाइल और एसपीएसएस के फाइल को ही ओपन करेंगे, पीपीटी नहीं चाहिए। पीपीटी बंद कर दें, इसको कोई ज़रूरत इसकी है नहीं, ये हो गया है बस। अब देखें, क्लिक करके शायद आ रहा हो। पीडीएफ खुली हुई है। दूसरी फाइल भी कुछ खोलना होगा, खोल लेंगे।
I'd like to apologize for the inconvenience. We will start shortly.
Okay. See here, this is one survey data type problem, and here problem is like that. Just so problem is like that. We have to develop a health profile of people in a city. Random sample of 50 people are taken, and following इसकी ज़रूरत है नहीं है, and following information are collected, and variables are considered like that: person number, you can say the ID number, gender, locality, age, monthly income, health score, personality score, and activity score. There are some variables. Some variables are the categorical variable, and some are the quantitative variables. Okay, and there are some coding scheme here. See here, gender I have coded like that. Suppose there is questionnaire, and these questions are given that questionnaire, and coding scheme for gender is 1 and 2. Suppose anyone is male, so I'll write 1 and 2 for female. And locality is also, there is a coding for locality 1, 2, 3, 4 4 localities are considered here, 1, 2, 3, 4. And monthly income, and on the basis of monthly income we also categorize the data below 5,000 rupees per month, and for 0, and 5,000 to 10,000 monthly income. So coding scheme is 1, 2, and 3 like that. So these are the coding scheme for the gender, locality, and monthly income. And problem is like that. So first, how will create the data file in SPSS? So see here, this is the just like other programs, we can double click on SPSS icon and this spreadsheet will be opened. Okay, and there are two view. You know, you just see here in the bottom there are data view and variable view button. Just see here, this is the data view and yeah. ये माउस जरा सा कर्सर कहीं और दूसरी तरफ भाग रहा है जो है, नहीं चल रहा है, इधर ला रहा तो उधर भाग रहा है, इधर लाना चाह रहे तो दूसरी तरफ माउस नहीं 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 मतलब कर्सर जो है, जैसे मैं यहाँ लाना चाह रहा हूँ तो उधर भागने लग रहा है ऊपर। आपको लग रहा है ठीक है, अब हो गया सही। So you see here there is two view, data view and variable view. You can toggle between this data view and variable view. So first we'll create the structure of your data file. So click on the variable view, and whatever variables are there, we'll write those variables and define those variables, then we'll enter the data. तो पहले देखें कैसे define करेंगे. Suppose first variable was the serial number, so in short we can write here SN, that is the serial number, and here you have to write in very short, just abbreviation, like abbreviation, serial number, and serial number is numeric. There's no, you cannot do any calculation on serial number, so you can leave as it is. There should not be any decimal point, because in serial number we need not any decimal. This width can be reduced. Suppose this is, if you reduce up to 3, that means 999 up to value 999 serial number you can accommodate in this. And label means now you can write the complete description of that SN, that means serial number of the person, serial number. And leave it as it is. Here here measurement is, you may take the scale type, because this is a numeric value, and unless still you don't want to do any calculation on that serial number, but you can leave scale type. Another variable is the gender, so you can write GN for gender, and there is a coding scheme, 1 for male and 2 for female. So this is also numeric value. So, and there is no decimal, so first reduce it to 0, and width can be 2 or 1, also you can write 1, but it's better to give the 1 or 2 or 3, like that. So suppose 2, width is 2, and this is the gender of person, like that. And here when you click on values, you observe there are 3 dots. Click on those dots. So write 1 here, and in label write male, and here add. Okay, and again write 2, and in label write female, and add. So 1 for male and 2 for female, and click on OK. So now we coded the gender. If in your questionnaire person is male, you just enter 1. If person is female, write 2. Okay? And what would be the measurement type? It would be nominal or ordinal? Nominal, because there is no reason to order male and female. So it will be nominal type. And third one is the, suppose locality. Locality, you can write locality like this. And here again you coded this, so you can reduce up to 2 here, 2 or 3, no problem. Locality. And here again you observe 1 for locality A, 2 for locality B, like that you can code 1, 2, 3, 4. I am not writing all the values. And here type will be nominal again. But when you write the monthly income, then data type will be the ordinal, because below 5,000, 5,000, 10,000, 10,000, 25,000 and 25,000 to 25,000 and more. So that will be the ordinal one. So in this way you can create a structure of your data file. हमारे पास create किया हुआ, मैं direct उस data file को open करता हूँ, and using that data file I'll analyze something. अब देखिए, just I told you how to create the structure. So already I created this structure: person, gender, locality, age, everything is given here. And after creating this structure, data will be entered in the spreadsheet. So whatever we noticed in our questionnaire, we entered in the spreadsheet. Okay. Now, after creating this data file, entering the values, first thing, there may be several types of question in a questionnaire. Sometimes you may need to compare the mean, or you may need to check the average of any population. Suppose here average health score, like that. Okay. So here two things in very beginning stage I'll do here. One thing, first I'll check the outliers in the data sheet. Outliers are the extreme values as compared to the rest of the data. Suppose if I check the outliers value in the health score, because most of the time I will deal with the health HS, that is health score, and sometimes I will consider the age, sometimes the activity score, personality score, all these things. So basically, if you want to check what would be the average health score of people in a given locality, so these are the sample values. 30 values are taken here, or 25 values are taken here. Okay. So first we'll check whether health score is normally distributed or not. Health score data is normally distributed or not. Before that, first we'll check the outliers. Outliers will disturb the normality of our data. Sometimes, or just I told you, outliers means extreme values as compared to the rest of the data. तो क्या होगा, कुछ values बहुत बड़ी होगी, कुछ values छोटी होगी, that will disturb the normality of the data. So how to overcome those outliers? Sometimes if you have the enough sample size, suppose sample size is 100 or 200, like that, so we may delete outliers values, extreme values, and rest of the values we can utilize for our analysis. But if you have the sample size not so large, suppose you have the sample size 25 or 20 or 30, like that, so unnecessarily you will not lose information. So we will replace those outliers with the nearby outlier, non outliers values. जैसे कि ऊपर आगे कोई 52 values outliers values, so nearby that value, suppose 42 or 40 is given, so you may replace that 52 with 42, but other information can be utilized for analysis. So first we'll check the outliers. So how to check the outliers in the given data sheet? So command is like that: analyze, descriptive statistics, and explore. Command is analyze, descriptive statistics, and explore. Suppose you want to check outliers in the health score that variable. So move this health score here, click on that and move here, health score, and click on plots, and this click on stem and leaf and continue. Options, click on options, here nothing to be done, and statistics, click on statistics. Here you can observe there is option for outliers, so click on that outliers here. You can unclick this descriptive also, but let it be here, and continue and OK. So these are the descriptive statistics, because I didn't unclick the descriptive, but here, see here, these are the outliers in the health score variable. Respondent number 21 and I think 10 are in the upper side, and respondent number 1 and 15 in the lower side. Health score of respondent number 21 and 10 in the upper side, and respondent number 1 and 15 in the lower side are the outliers. And this black middle line is called the median of these values. Okay. So there I purposely just did alteration to show you how to outliers can be displayed in the, this is box plot, this is the box plot, and these two outliers in the upper side and lower side. So I just told you what is the remedy to remove this outliers, to replace with the nearby outliers value, or if sample size is large, so delete whole record, no problem. Okay. So now you can detect outliers separately in the male and female. Sometimes as a whole, outliers is a 10 number and 20 number, like this. You can separately observe outliers in male and female. So how we'll do this? So click on data, split file, or you can directly do like this also, analyze and explore. And here outliers we already considered here, outliers here, continue, but here in factor list move the gender in this factor list, okay, and okay. So here two box plots are displayed, one is for male, another is for female. Now in the case of male, in the upper side respondent number 10 is the male and that is the outliers value, and in the case of female respondent number 15 is outliers in the lower side, and it is given by star, that is given by the 0 or O like that, but it is given by star. That is because of mild outliers, that is not too much different from the non-outliers value. So in this way you can check the outliers value, and sometimes you may remove or sometimes replace to get your data normally distributed. Next step, now I want to check whether health score data is normally distributed or not. So there are 4 ways to check the normality of data. One is histogram with normal curve. Here SPSS will draw the histogram along with normal curves. Using that you can observe whether data is normally distributed or not. Every time you will not get the exactly normal distributed. Sometimes it will be little bit skewed either in the left side or in the right side. So you can say data is approximately normal, and you can use the parametric test. So one is the histogram with normal curve, another one is the skewness and kurtosis. What is skewness and kurtosis? Skewness gives the symmetry of the curve. It may be sometimes right skewed, sometimes left skewed, and kurtosis gives the peakness of the curve as compared to the normal curve. In normal curve it is symmetrical from both sides, and it is neither peaked or nor flat. So we may frame the thumb rule: if the value of skewness and kurtosis is between -3 to +3, we can say the data is approximately normal. Okay, sometimes you may frame the thumb rule like that, -2 to +2, but don't take a wide range like -10 to +10 like that. So -1 to +1, because the mu plus minus 1 sigma, 2 sigma, 3 sigma we generally consider the reliability theory. That's why I am telling you can frame the thumb rule -3 to +3. If your values are in between that, you can say the data is approximately normal. Third procedure is through statistical test, Kolmogorov test and Sapir-Whorf test. Though 2 tests are available here, but problem is that here using these 2 tests, either you can conclude data is approximately normal or not. बीच की चीज नहीं है कि approximately normal. Your hypothesis will be either rejected or accepted, because under H0 will write data is normally distributed versus H1 it is not normally distributed. So after applying those tests, H0 will be either rejected or accepted. If it is rejected, then there will be problem. You cannot say it is approximately normal like that. But through histogram, normal curve and skewness, kurtosis, you can say this is approximately normal. So I will do all these things here. So I am going to check normality of health score data. So analyze descriptive statistics, frequencies, click on frequencies, okay, and move health score in this window, okay, and click on charts and click on histogram and show normal curve on the histogram, okay, and then continue and okay. See here, fabricated data है, बहुत ज़्यादा ही नॉर्मल दिख रहा है, रियल वर्ल्ड में जाएंगे तो कुछ स्क्यूनेस मिलेगा. सो अभी भी नॉर्मल एग्जैक्टली नहीं कहेंगे, थिकनेस थोड़ी सी ज़्यादा लग रही है मुझे जो है. सो बट यू कैन से दिस इज अप्रॉक्सिमेटली नॉर्मल. सो पैरामेट्रिक टेस्ट कैन बी अप्लाइड फिर दिस हेल्थ स्कोर डेटा. इसी तरह समटाइम यू वांट टू कंपेयर मीन हेल्थ स्कोर ऑफ मेल एंड फीमेल using t-test, because our sample size is 25. So it is below 30, obviously t-test will be used. And even if you have a sample size 50 or more than 50, so here only t-test is available, but it will be approximated to the normal test. So then no need to panic. Sample size is large. Why you use the t-test? You use the t-test. SPSS will automatically adjust those values. Okay. So suppose you want to check normality of male and female data separately, whether male data is health score data related to male and health data related to female are normally distributed or not. So first we will break this data file internally on the basis of gender, then again we will repeat the same steps and we will check the normality of it. So what we will do here, data split file, and here click on organized output by groups and move gender into this box, okay, and click on OK, and again repeat the same steps. Analyze descriptive statistics, frequencies, and already these values are given here. Just click on OK. So see here, this histogram is for male. This is the positively skewed. This is positively skewed, and similarly you can observe here female data is negatively skewed, but as a whole data was approximately normal, or sometime it was looking like exactly normal. But here when we separated male and female data, so male data is positively skewed and female data is negatively skewed. But agar use kare little bit like normal, you can say the approximately normal. So one method is जो we generally use histogram with normal curve. अगर आप टेस्ट लगा रहे हैं अपने रिसर्च में and before applying t-test or correlation analysis, regression analysis, if you write these steps, that means you checked your data, health score data. Suppose in my case health score data. So you checked and you found that your data is approximately normal. Then you are applying the t-test. So referee will be too much impressed. तो उसे लगेगा कि आता है इसे, मतलब क्यों लगा रहा है, ठीक है. अब इसमें देखिए एक चीज और बताया मैंने, देयर इज अनदर मेथड फॉर स्क्यूनेस एंड कर्टोसिस. सो इसी के साथ डिस्क्रिप्टिव स्टैटिस्टिक्स की भी लिस्ट डिस्प्ले हुई है. आप देखेंगे ऊपर में, जहां आउटलायर्स हम देख रहे थे, अब देखिए यहाँ पर एज ए होल जो है ये मेल फीमेल का सेपरेट है और इसका कंबाइंड भी है. नाउ यू कैन ऑब्जर्व हियर, here two values are given, skewness and kurtosis in the case of male and female. And suppose we framed the thumb rule, if value of skewness and kurtosis is between -2 to +2, then we can say the data is approximately normal. And in our case, these values are between those limits. So here on the basis of skewness and kurtosis, you can also write data is approximately normal. So this is another method to check the normality of your data. Third procedure, that is very strict procedure, through test. Analyze descriptive statistics and explore. Just reset कर दें. Health score, move here. Plot. Click on plot. Unclick stem and leaf. And then normality plots with tests. Click on normality plots with test and continue. Because here normality plot means there will be QQ plot, that is quantile plot. And if most of the values nearby that diagonal line, then again we can say the data is approximately normal. And along with that, table will be displayed and p value will be there, and using that p value you can conclude that whether data is normally distributed or not. So see here, see here, ये दिख रहा है ना आपको? Test of normality. There are two procedures, two methods for testing normality is given. One is Kolmogorov-Smirnov test and another one is the Sharpio-Wilk test. WILK, both are the Russians. And variable is health score. Variable is under consideration is health score. Some statistics are given. You are not concerned with these statistics because SPSS displays too many things and some things are useless for us. So here we are concerned only with the significant value, P value. P value कितनी दी गई है इसमें? 0.080. Okay. That means under H naught. अभी मैंने बताया था कि पेन होगा क्या क्या? इस पर लिखना है. है किसी के पास? So what we'll do first, we'll state null hypothesis H naught. Health score data is normally distributed. Normally distributed. Under H naught, we'll state like this. Versus H1, data is non-normal, not abnormal, non-normal. So here we are concerned with the P value. In our case, P value is 0.080. Here P value is 0.080. Okay. Suppose you fix alpha 5%. So alpha 0.05. You fix alpha 0.05. So what we will conclude here now? Just tell me whether hypothesis will be rejected or accepted. अभी शाह मोहम्मद साहब ने आपको बताया है, इसलिए मैंने पूछा. On the base, I written two things. One is alpha, another thing is P, and you have to conclude whether your hypothesis is to be rejected or accepted. रिजेक्ट होगा. अब हम रूल लिख रहे हैं. अब बताइएगा रूल क्या है. रूल, if P is less than equal to alpha, if P is less than equal to alpha, reject H naught. Reject H naught. अब आपका P क्या है? 0.080 है. ये अल्फा 0.05, छोटा तो नहीं है. नॉट लेस देन. H नॉट क्या होगा? एक्सेप्ट हो जाएगा. ये अगर रिजेक्ट हो जाता तो हमारा डेटा अच्छा, यहाँ पर ज़्यादातर हम चाहते हैं कि हमारा H नॉट रिजेक्ट हो जाए. ज़्यादातर केसेस जब हाइपोथेसिस टेस्टिंग करते हैं आप रिसर्च के लिए, तो वाट एवर योर रिसर्च प्रॉब्लम यू स्टेट अंडर द H1, and we always try to reject our null hypothesis and you want to get the significant result. But here we want to accept H naught, because under H naught we stated that data is normally distributed. If H naught is accepted, then it will be very good. Through test we shown that data is normally distributed. In our case H naught is accepted. यहाँ पर अगर लेस होता तो रिजेक्ट हो जाता, लेकिन यहाँ पर क्या है, since P is greater than alpha, so accept H naught, and H naught is stated like that health score data is normally distributed. So through test we also concluded that data is normally distributed. So thoroughly we can use parametric test for this data, because through test we also shown that data is normally distributed. So three methods I shown you, four methods. One is histogram with normal curve, through skewness and kurtosis, then statistical test, and QQ plot. That means if most of the values are near diagonal line, then data can be, health score data can be can be called the approximately normal. तो यहाँ पर देखिए diagonal line के ज़्यादा नज़दीक है, बिखरी हुई नहीं है सब, ठीक है. So in this way you can check the normality of given data. अभी इसके जैसे health score में देखा आपने, you can check the age variable also, you can check the activity score also, you can check the personality score also. whatever variables you are going to study, you can check the normality of your data of that variables. Okay. Now come on to the statistical test. अब ये प्रॉब्लम आपके पास आ गई, जस्ट I checked health score data is normally distributed. Now I raise one problem related to this health score data और हम आपको उस प्रॉब्लम को शो कर देते हैं. अब वन सैंपल टी टेस्ट, टू सैंपल टी टेस्ट, पेयर टी टेस्ट, 3 हम एप्लीकेशन इसी हेल्थ स्कोर डेटा पर हम यूज करेंगे. प्रॉब्लम इज स्टेटेड लाइक दैट. आप अपने प्रॉब्लम को इसी बेस पर ट्रांसफॉर्म कर सकते. यू कैन ट्रांसफॉर्म योर प्रॉब्लम on the basis of this problem. Problem, this is one simple t-test, application of t-test. You know, there are some assumptions for t-test. I just stated in the beginning. Observation should be independently taken from the population. Observation should be the quantitative, qualitative नहीं होना चाहिए. अगर qualitative है तो उसकी scaling वगैरह करके लोग कर लेते हैं, लेकिन वो हम suitable नहीं समझते. And parent population should be normally distributed. We just check normality of the data, and also if we compare two population, the population variances should be same. तो वो भी हम देखेंगे. So first problem here I stated, average health score of normal person is supposed to be 55. In medical book, suppose it is written that average health score of healthy people is supposed to be 55. Health score of 12 persons from a community whose living conditions are suspected of causing poor health score are recorded in health data file. In my health data file I recorded the values. Do these data justify the suspicions regarding the health score of the community? अब health score data को देख के लग रहा आप सोशियोलॉजी के हैं, मेडिकल साइंस के हैं, आपको लग रहा कि हेल्थ स्कोर, जो एवरेज हेल्थ स्कोर है, दैट मीन्स हेल्थ स्कोर फॉर हेल्दी पीपल शुड बी 55. And you are observing health score of the community is below 50. Some people may have the more than 55, but most of the people having the health score less than 55. So you want to check whether whatever you are just observing in this sample, this is also true in the population or not. This is our problem. Okay. So what we'll do first, we'll state your research problem in the form of null hypothesis or an alternative hypothesis. So whatever you are thinking, you will write under alternative hypothesis. So here under alternative hypothesis we have written mu is the population mean health score of the people in the population. So mu is less than 55, and H naught will be written first. We'll write the H naught null hypothesis. There is no mu is equal to 55 versus whatever you are observing, that will be written under H1. Mu is less than 55. So under H naught mu is 55. Here description is also written. Average health score of people of normal person is 55 versus less than 55. Okay. Now what we'll do here, test for single mean. We know if sample size is small, we use the test t-test for testing single mean. So how will apply this? So first we shall take the analyze, compare means, and take the one sample t-test here. And your variable of interest is health score. So click on health score and move here. Okay. Test value is 55. You written test value is 55. And here, if you can see the option, that means 95% confidence, that means alpha is 5%. Let it be continue and okay. So see here, this table shows the one sample t-test. Health score variables are given here. You can take at a time health score, personality score, activity score, all variables can be tested at a time, but hypothesis will be different. Hypothesis will be different for all the 3 variables. So here health score using t-test, when you apply t statistic or t statistic का जैसे formula है t is equal to x bar minus mu over S over square root n. This is the formula in statistics for one sample t-test, where x bar is the sample mean, mu is the 55, and s is the sample variance, and n is the sample size. So after using this formula, this t value is calculated, and this will follow degrees of freedom. Degree of freedom is the number of independent observation. So here degree of freedom will be n minus 1. So no need to go on that. So here there are I think 14 values. So n minus 1, that means 14 minus 1, that is 13. Basically we are concerned with the p value. Here p value is given 0.14. P value is given 0.174. One point is to be noted: if your hypothesis is one-tailed, because I just written mu is equal to 55 versus mu is less than 55, when you write your alternative hypothesis less than or greater than, this is the one-tailed test. One-tailed test. Less than left-tailed test, greater than right-tailed test. If you write mu is equal to suppose 55 versus mu is not equal to 55, then it will be called the two-tailed test. So in our case, this is the one-tailed test. So here p value is for the two-tailed test. P value is given for the two-tailed test. So what, before comparison, what we do, if p value is given for two-tailed test and our hypothesis is for one-tailed test, so we divide this p value by 2, then compare. So what we do here, suppose p value will be here 0.147 by 2. You can write this is the p star, or let it be p only. So after dividing, we will compare. Again rule will be the same. If p is less than or equal to alpha, then reject test not, otherwise accept it. Even if you divide by 2, what you will get? P value will be point something like this, 0.1, point something like that. So again, if you see here, p values, I will show in our problem what is p value. So see here, p value in our file, p value was 0.066. So our hypothesis was one-tailed. So what we did, we divided by 2. So p value become the 0.033 in that case. Now after dividing, we compared here, 0.033 is less than 0.05. So H naught will be rejected. H naught, because I written the rule for rejection or acceptance. If p value is less than or equal to alpha, then reject H naught. So here p value is 0.033, it is less than 0.05, so H naught will be rejected. H naught will be rejected, that means whatever we are thinking, that is correct. So in conclusion, it is written like that. So it may concluded that at alpha, that means 5% level of significance, that there is enough evidence in the sample that may conclude that poor health in the community due to their bad living condition. What you were observed, poor health score, you just thought that poor living condition may be the main reason for the poor health score, that is correct. And how much with confidence you can say this? You can say this with 95% confidence. That means if you take similar sample, 100 similar sample, so in the 95 sample we will get the same result. That is 95% correct. Okay. So this is the testing of single mean using t-test. Now I will compare the two means. Next problem is like that. With reference to our health data, suppose we wish to test, is there any significance difference between mean health score of male and female? Male, female के mean health score, is there any difference? So under H naught again will state like that, there is no significance difference between mean health score of male and female. अब यहाँ दो तरीके से प्रॉब्लम स्टेट कर सकते हैं. If you observe mean health score of male is greater than female, sometime you may observe mean health score of male is less than female. If you are not observing, just there is some confusion like that in your mind, So you can write under H1 mu mean health score of male and female are not equal. So there is straightforward two statements whether mean health score of male and female are same or not. So here I just stated like that under H0 there is no significance difference between mean health score of male and female versus H1 there is some significance difference. So that we just observing there is some significance difference or there is some difference in the mean health score of male and female. Okay. So how will perform this analysis? First, what we'll do here again we need to check the normality of male data and female data. I just checked, we did like that split data file and check the health normality of male data and female data. Already I did this. So, but when you will split your data before analysis, we will again reset that. So first we will check whether it is reset or not. Split file. So here you see here your data file this time is bifurcated in two parts. Male data is one part and female data is another part. So before analysis we will reset it. We'll press on reset, or you can analyze all the cases and do not create groups. Okay. Now come on to the data sheet. Now analyze and compare means, and then independent sample t-test. Here both the population are independent, because next I will go on to the dependent sample t-test. Here both the population are independent. One population is male, another population is female. Suppose you want to compare the mean marks of architecture students in calculus with the mean marks of mechanical students in the calculus. So there are two separate populations, architecture students and mechanical engineering students. So here similarly there are two separate populations. So what we will do here, test variable is health score, move here, and option see here 95%, that is 5% alpha is taken here. Now grouping variable is gender, we want to compare on the basis of gender. So click on the gender and move here, grouping variable. Here see there are two question marks. So define these groups, click on groups and write here, because you coded like that, one is for male, two for female. So write under in group 1, 1 and group 2, 2 and continue, then okay. Okay. See here, here there are two tables. One is given health score and their mean, standard deviation, standard error for mean is given. So we are not concerned with the first table. Basically we want to test equality of means for male population and female population. Here two rows are given, equal variances assumed, equal variances not assumed. I told you for applying this parametric test, one of the basic assumptions is that population variances should be same. Yani male variances of male population, female population should be same, population variances. So here Levin's test for equality of variance are given. Automatically SPSS displays the Levin's test for equality of variance, whether two variances are same or not. And P here, P value is given here also 0.219. 0.219 is given. Under not here again we will write here sigma 1, suppose variance of first population, male population, or sigma f, female population. Sigma is the square is the variance. Okay. So under H naught, variance of male population and female population are same. If our p value is greater than alpha, then H naught will be accepted. That means assumption will be fulfilled. So what we observe here, here significant value is 0.219. That means p value is greater than alpha. Alpha I taken 0.05 and this probability value is, this is p value is the probability. 0.219, I think 0.219, yes. This is greater than alpha, so H naught will be accepted. Whatever assumption should be satisfied, it is correct. That means two population variances are same, and this is done by the Leven's test for equality of variance, and SPSS displays in the first three columns like that. Now come on to the main problem. See here, and against this you see there P value is 0.944. So again, if you observe this P value is greater than alpha, again alpha I taken the 0.05, so H naught will be accepted. That means mean health score of male and female are same. There is no any significant difference between mean health score of male and female. So here you can see also. In our case, it is less than alpha. I used a different data file, so in that p value is greater than alpha. But here in our slide, it is 0.031. This one is less than 0.05. That means there is significant difference between mean health score of male and female. Now come on to the pair t-test. Pair t-test is used when data is in the bivariate form. Bivariate form is, suppose health score of a locality are given and you check the poor living condition is the major cause for the bad health score or poor health score. Okay. So good living conditions are provided to the people of that locality, and after a month again health score of those people are recorded. अब यहाँ पर problem क्या है? Same set of people will be considered before and after. Suppose आपने 10 students और 20 students की class का example लिया, and first test is taken of those students and their marks are recorded, and 1 month tuition or coaching is given to those students, and after a month there again marks are recorded after test. So is there any difference between marks before coaching and after coaching, or students are you can say that whether students are benefited with the coaching or not? दूसरा एग्जाम्पल इस तरह से ले सकते हैं कि स्लीपिंग पिल है, कोई मेडिसिन है, कोई 10 पेशेंट्स आपने लिए, उनको जो नॉर्मल वे में जो सोने दिए, and after giving that medicine again their sleeping hours are recorded. So you want to check whether there is an effect of that medicine or not. So same set of individuals will be considered before and after. So here also, suppose 20 people, those people are taken whose data are collected before providing the better living condition, and after providing better living condition again their health scores are recorded. So in our data file I written health score 1 like this. See here there is a last column health score 1. So on the basis of health score again I created just this is fabricated data, just somewhere I increase, somewhere I decrease the values. So now how will you use, and a hypothesis of interest will be like this: under H naught mu before is equal to mu after. There is no significant difference between mean health score before and after, but versus H1 mu B before is less than mu A, means mean health score before was less than after. Okay. So how will analyze, compare means, and see here paired sample t-test, and here variables are health score, move here variable number under 1, and health score 1, health score after providing the better living condition, this will be here. Okay, and option this is 95%. Okay, and then okay. So see here, here p value is 0.000, last column, see the last column, p value is 0.000. That means here again p value is less than 0.05. So H naught will be rejected. Rejected, that means after providing the better living condition, mean health score of people of that locality is improved. And this is highly significant. Even if you take alpha 1%, then with 99% confidence you can say your result is correct. With 99% confidence, because p value is 0.000. If you take alpha is equal to 1%, that means 0.01. Even though this p value is less than alpha. So this is highly significant. When your p value is like that, 0.000, then obviously this will be the highly significant value. So on the basis of this analysis, you can say after providing the better living condition, mean health score of people of that locality is improved. So in this way, you can analyze the data using t-test. So up to here today, inshallah tomorrow I will continue. We will compare more than 2 means and simple linear regression analysis and multiple linear regression analysis. Material बहुत है लेकिन time बहुत कम है, तो जितना हो सकेगा करेंगे.